So, percent increase, we're going to build on that lesson that we had just before break. Results were very good for practice 23. Obviously, it was just a quick review of what a percent is. Now we're going to start applying some of these things and take a couple shortcuts, all right? We all love shortcuts in trying to find out the answer. What we're shooting for today is to be able to know the meaning of a percent increase and decrease, and be able to use percents to find answers to real life questions. We see percents all the time in the real world, so that's definitely something that we can say, hey, we're learning something we can apply later in life, which is always a good feeling. All right, so a percent increase is when you add the increase to 100%. Remember that 100% means the whole thing. All right, one whole thing. So if you did the front page of your homework assignment, you did the whole thing. Now, if you did the back page, I gave you extra credit. An extra 10 points would have been 200%, right? So we talked about a number that's bigger than 100, because if you did more than what you were supposed to, you're going to get over 100%. So that's what this means. Let's take a 25%. Are you kidding me? And if you see this beautiful picture that I'm using as like my background, that is a picture we took while we were snowmobiling on a night of lake. Beautiful day, sunshine, and just had some great views. All right, let's see if my pen will work this time. 25% increase. Wow, that's bad handwriting. Increase, if you can't tell what that is. So we can show this as a number that's greater than 100%, so that we can just kind of add in the increase. So we're going to do 100% plus the 25, and that's going to be 125%, right? So we can use that number in our calculations. Now that number as a decimal, remember, is 1.25. The 1 represents the whole amount, the 25 represents the increased amount. Okay, now what about it for a decrease? Well, this is when you subtract the decrease from 100. I'm going to use a 25% decrease just to kind of stay consistent. Ooh, handwriting was good until that last part. And I'm going to take the 100%, the whole amount, I'm going to decrease it by 25%. And the key to this is 75% remains, okay? So I'm going to use 75%, which really is 0.75. Remember, we got to kick that decimal 2 times down the street. 2 times to the left, that is. All right, so a little setup for what we're going to be doing today, and let's get right into it with some real life questions. Now, to be honest, I wrote this question last year, right before kind of everything went on, like right before it really blew up. So kind of interesting how this question is so important now to, whether we're coming back to school and what we're going to reopen and such. So doctors are quickly studying how the coronavirus is spreading. They calculate the disease is spreading at a steady rate of 6% per week, and that is true. That's how they kind of were averaging this out. Let's say at the beginning of the week there were 40,000 people diagnosed with the coronavirus. All right, now how can we figure out 6% of 40,000? There's a couple of different ways. The first way is, let's find 6% of 40,000 and then add it to the original. So kind of like what we were doing in practice 23. So 6% times 40,000. Remember, we were just taking the percentage, multiplying it by the whole amount. So we got to change this to a decimal first, 0.06. When it's a single digit, you got to kick it twice. And so 0.06 times 40,000. And then what do? We go to our trusty calculator, and so I'll just quickly pull it up and do 0.066 6% times 40,000. All right, so there's 40,000, and that's 2,400 people. All right, so that's how many people were being infected on the increase. If this was increasing at 6%, oops, not money, people. Now, how many people total is that? All right, well, if we had 40,000 people and then we just experienced a 6% increase after 1 week, we're now up to 42,400. Clearly, since then, the numbers have gone way up, and we've seen a lot of unfortunate things happen as a result of this. But there's one way you can figure out a 6% increase. Now, there's a faster way. I told you I would kind of teach you the shortcut, and maybe you already knew this because this is how you figure out tax when you're buying an item, or how you might figure out a different percent increase. Let's find the population of people affected by using a percent increase, meaning let's take the percentage, 6%, and add it to 100. So we're going to do 100% plus 6%. So that's simply 106%. And so it's going to be a lot easier to use that number than to add, or sorry, it's a lot easier to add 100% and 6% than it is to add like the 40,000 and the 2,400, at least in our head, right? Now we're still going to multiply the 106% by 40,000, the original amount. Now I'm going to put the percentage in parentheses. I'll explain why in a little bit. Doesn't matter which way you do it, we're still multiplying, right? So 40,000 people times 106%, which again, we got to move 2 times, 0.06, 1.06 that is. Now, back to the calculator. Calculator says 40,000 times 1.06. And what do you think we're going to get? Exactly, 42,400, which is the same number we got after we added the 6% increase to the original. All right, so what would happen if we wanted to find how many people would be affected after 2 weeks? Well, to do this, we'd have to take our 1 week total of 42,400 and multiply that by another 106%. Because again, we want to keep the 42,400 and then add 6%. So that's why we're using a number over 100%. If we just use 6%, this number is going to decrease. So again, remember that in order to multiply, we must change to a decimal, move it 2 times for 0.06, and calculator time says that answer, so it's already in there, so I can just do times, because I'm going to use my answer, 1.06 is going to end up at 44,944. Okay, so once we've got that, let's go ahead and put that down, 44,944. Now, where are we really going with this? Well, so there's a real life example of how we're going to use percent increase and decrease. Now let's go ahead and just get real comfortable. If we want to take 440 and increase it by 12%, the fastest way to do this is to put the starting amount out front and then add 100% to 12. Add because it's increasing. Now, did we really have to write that step? No. I just wanted to kind of show you it so that you didn't kind of wonder what I was doing. Where did I get 112% from? I just added 12 to 100. Now I do 440 times, I got to change it to a decimal. This is what we were really trying to work on in practice 23. I move it 2 times. I go ahead, I plug it in the calculator. I'm going to get a number bigger than 440, and it's going to be 492.8, right? We should see that number go up because it's a percent increase. If I start at 440, it's going to rise up to 492.8. Next one, we've got a 68 increase by 8%. I'm going to go right to the increase percentage. I'm going to take the 8% and add it to 100. Again, we do this because it's a lot easier to add 100 to something than it is to find 8% and then add it on later. So I'm already at 108%. I am going to show the step where I move the decimal always 2 times. I plug it in the calculator. I get 7344. Okay? For this last one, I'm going to do a quick poll question. So there you have it, 3.5% added to 100% to make a number larger than 120. Let's go ahead and look at one more real-life example that applies this to the real world, like savings accounts. These are classic ways to see an exponential increase. So Adriana has a savings account that promises her a balance of 0.5% per year. That's not too bad. She has $720 in the beginning of the year. What would the balance be at the end of the year if she does not withdraw any money? That's the key. Doesn't take any money out, doesn't put any additional money in. Well, her original amount is $720. She wants to increase this. This is going to add to her bank account. So add the 2.5% to 100. That's going to make 102.5%, right? 100% added with the 2.5. That's all we're doing here. So once we do that, we change it to a decimal, 1.025, and all banks kind of work this way. She's going to end up with $738 just by letting her money sit. How many people drink coffee? Any coffee drinkers out there? I know you're really young. You shouldn't be putting caffeine in your body at such a young age, but good, Caleb. Nice. Just good sleep, rest, eat well the night before. Excellent. Excellent. I'm not a big coffee drinker. I do have a little bit of caffeine in my life, but not a big fan. But anyways, let's say a cup of coffee that people like to drink really hot is cooling down, and it's decreasing at a constant rate of 8%. So let's say the coffee starts at a temperature of 200 degrees, and let's do this the old way. Let's find 8% of 200 and then subtract from 200 degrees. So basically what we were doing last time is 8% times 200. We change it to a decimal, 0.08 times 200, and then we find that to be 16 degrees, right? Now, we got to go one more step. The coffee isn't 16 degrees, it'd be freezing. It'd be a block of ice, right? That's not coffee. I got to take 200 and subtract 16 and get 184 degrees. So if I started at 100%, which is full temperature, and I subtract 8%, because that's how much it's losing, 92% of the heat remains. That's the key, because if I did 8%, that's going to bring the temperature all the way down to 16 degrees. The temperature is going to have 92% left of what it originally had. So what will the temperature be after 1 minute using the percent decrease? Well, let's go back to that other model where I put the starting value here. I multiply it by the 92%. How much of 100 is left? I change that to a decimal, 0.92. I multiply, and guess what? I'm not even going to use the calculator because you already know it's 180. Real life question, and one that hits close to home. Paul V. Moore's enrollment has been going down. When I started here, we were a AA school. Now we're a single A school. So let's say that it's decreasing at a constant rate of 4% per year. What percent remains after 1 year? So important to go ahead and figure out that this is 100 minus 4%. Now I'm writing this down to show work, but we all knew that this was going to be 96%. So 96% of the student population remains. Now if they started the year with 910 students, how many will there be next year if this continues? Well, I use the 96%, not 4%, because that's how many people are going to leave. We want to see how many people are going to be left. So again, when we do this, we change it to a decimal. Move it 2 times, you put it in your calculator, and you get 873.6, which we don't really want to have 0.6 of a student. Let's round up and say 874 students will be here in Central Square next year. Actions say it all, subtracting the percent from 100. Then multiplying. So if we start with 620, the initial amount, we're going to do 100% minus 10%. Why did I subtract? It said decrease. So that's 620 times 90%. That's how much is going to be left. 620 times 0.9. Throw it in the calculator. How about 558? All right. Next up, how about 22.5 by 8%? Well, I'm going to kind of skip the subtraction step. The starting amount is 2250. I can do this. You should be able to do this. 100 minus 8. How about 92%? So we're going to skip that subtraction step, just because it's extra writing, things that I can handle, why not? I am going to change this to a decimal, 0.92, multiply it up. How about a smaller number like 20.7, okay? So just make sure you subtract 3.5% from 100. You're going to get 96.5.